Hello, welcome to video number 79. I'm Mr. Miller, and today we're going to start doing something that's probably new to most of you. This is about rational exponents. And we're going to talk about how they're related to radicals. Okay, so the first thing we want to talk about is this. We want to explain why x to the fourth would equal the fourth root of x. What's the connection here? Well, if we multiply x to the fourth times itself 4 times, x to the 1/4 times x to the 1/4 times x to the 1/4, and then one more time times x to the 1/4, and we want to get a feel like what does this mean? Well, we should be able to add the exponents. If we multiply powers, we add exponents. So this would be x to the 1/4 plus 1/4 plus 1/4 plus 1/4, which is actually x to the first. So when I multiply this thing by itself 4 times, I get x. That means that x to the 1/4 should equal the fourth root of x. Because that's what the fourth root of x is. The fourth root of a number is what you multiply by itself 4 times to get the number. And apparently that's what x to the 1/4 should do. Okay. Why does x to the 1/2 equal square root of x? This is a little bit easier to write. If I multiply x to the 1/2 times itself, we would get x to the 1/2 plus 1/2, which equals x to the first. So x to the 1/2, when you multiply it by itself, you get x. Well, that's what square root does. So x to the 1/2 must equal the square root of x. Okay, so we want all the rules for fractional exponents to be the same as regular exponents. And in order for that to be true, we see that x to the 1/2 would have to equal square root of x. Okay, so let's practice here. So we have some expressions here with fractional exponents. Let's rewrite them as radicals. So 10 to the 1/2. That's the same as the square root of 10. So notice that the denominator of the fraction becomes the index of the square root. So we could put a 2 there. If we don't put anything there, we assume it's a 2. Okay, so p to the 1/3, that's equal to the cube root of p. M to the 1/5, that's equal to the fifth root of m. Alright, these are a little bit different. I can kind of break this fraction up. I can think of this as x to the 1 or to the 7th all to the 1/3. Because a power to a power we multiply. So 7 times a third is 7/3. So I'm not changing anything. And we can then write this as a cube root. This is the cube root of x to the 7. So it's x to the 7 to the 1/3 power. 1/3 power means cube root. So we have that. So notice that the numerator is the power of x, and the denominator is the index on the root. Okay, so this one we can break up again. This is going to be, think of this as b to the 3rd all to the 1/4. And that would be the fourth root of b to the 3rd. Okay, this one, I'll skip the middle step. I'll just write the radical. So we know it's a square root because there's 2 in the denominator, and 9 is the power. So this is a square root of w to the 9th. Okay, let's do some with numbers. And I don't want to confuse the issue, but here I'm going to kind of break them up differently. But first, I just want to say, how would you do this on your calculator if you wanted? Well, you could just do 8, hit the exponent key, and put parentheses around the 2/3. And it'll do 8 to the 2/3 power. Now, if we're kind of doing it by hand, actually here, I would break it up this way. 8 to the 1/3 squared, which is the cube root of 8, all squared. Cube root of 8 is 2, and 2 squared is 4. So this would equal 2 squared, which is 4. Okay, let's try this one. So when it's a number and I'm simplifying and I'm not using a calculator, I'm going to do 16 to the 1/4 cubed. Now the reason why I'm doing it this way is if I cubed it first, I would get a really huge number and then it'd be hard to take the 4th root. So 16 to the 1/4 is 2. That's the 4th root of 16. So this is 2 to the 3rd, which is 8. All right, 32 to the 1/5 to the 3rd power. So we're taking the 5th root. So what do you multiply by itself 5 times to get 32? Well, the answer is 2. And then 2 cubed is 8. So like I said, if you have a calculator, you can just do it in one shot. Do 32 to the 3/5. All right, so, but I'm showing you kind of how you might do it by hand. 16 to the 1/2 to the 5th. So I'm going to take the square root first. The square root of 16 is 4. And 4 to the 5th is 1024. So 1024. Okay. 27 to the 4/3. This would be 27 to the 1/3. So I'm going to take the cube root first, and then raise that to the 4th power. The cube root of 27 is 3. And 3 to the 4th is 81. All right, last one of these. So we're raising to the 5th power, and we're taking the square root. Let's take the square root first. So this is 9 to the 1/2 to the 5th. That's just the square root of 9, which is 3 to the 5th. And 3 to the 5th is 243. Okay. Now, all the usual laws of exponents apply, whether they're positive, negative, or fractions. The usual laws apply. So in a problem like this, we're going to do what we always did. We're going to multiply the coefficients. So 2 times 4 times 4 is 32. And we're multiplying power, so we add exponents. So this can be m to what we get when we add these numbers. 2 plus 3/2 plus -2 is 3/2. So I'm going to leave it as 32 m to the 3/2. All right, here. There's only 3 times 1 is 3. And to get the power of b, I have to add exponents. 1/2 plus 4/3. You can use the ABC calculator on your button on your calculator. This would be 3/6 and 8/6. That's 11/6. So 3b to the 11/6. Okay, a power to a power we multiply as usual. So this is going to be p. 3/2 times -2 is -3. And I'm going to write that as 1 over p to the +3. Again, power to a power we multiply. 1/2 times 3/2 is 3/4. All right, when we have division, we subtract exponents as usual. So first, divide the coefficients. 2 divided by 4, that simplifies to 1/2. Then we're going to subtract the exponents. 7/4 minus 4/3. All right, let me see if I can figure this out here. This would be 1/2 x. That'd be 21/12 minus 16/12. I believe we get 5/12. Okay, so yeah, times 3 would be 21, times 5 would be, times 4 would be 16. All right, good. If I'm wrong, you're going to have to let me know in class. Here we go. 4 divided by 2 is 2. And we're going to subtract the exponents. 2 minus 1/2. So it would be 2x to the 3/2. So all the rules apply. We do the same thing as we normally do. Okay. I got the last set of examples here. We want to go backwards. We want to write these radical expressions as x to some power. Okay. We want to write them with rational exponents. Okay, so we could think of this as x squared. We're taking the cube root of that, so that's the same as the 1/3 power. And a power to a power, we multiply x to the 2/3. Right, even easier is to realize that 4 goes in the denominator, 5 goes in the numerator of the exponent. So this would be m to the 5/4. This would be x to the 7/3. And this very last one, this would be d to the 6/11. 11ths. All right, there we go. So here's your journal assignment. You're going to rewrite these as radicals. And you can use your calculator to do these. We're going to find the values of these expressions. So I would do the root first and then the power if you're kind of doing it by hand. You're going to simplify these. Again, you're going to add exponents here and subtract exponents there, and then rewrite these. Once you get to the hang of this, it'll be a snap. Good luck.